Hey guys, welcome back again in our this training. This is the second training in our this series about the latency-based data center or ZEN selection. So far, we have covered the overview, the configuration on a mobile portal, the Zscaler formula, how it detects the low latency data center, and the minimum requirement and how it works. Now the lab and the log part is remaining, and we're gonna cover this two topics in this video. Okay, so first of all, let's just very quickly check what is our configuration now. So you can see this is the app profile for our training, and let me log into our lab box, and let me show you very quickly what is the app profile in use. Okay, so I'm logged into this box, and in this box, what you can see is that ZCC is running, right? This is a pack at shapeskills.in as a user. We're running Zscaler Tunnel 2.0, and the app profile is Training Tunnel 2.0 App Pro, right? So this is the app profile in use, and this is the forwarding profile, right? Correspond to this app profile. Let me go to the forwarding profile and see what is the latency based ZEN selection configuration. So this is the forwarding profile. I opened it. I can see this option dynamic ZIA services assignment is enabled. We have a 30-second interval configured, minimum 3 probe sample size, and the threshold is configured 1. Threshold 1 means 30% more than 30% latency between these primary and secondary DC, and there will be a failover. Okay. All right. So I think the configuration is okay on a portal. Now, one thing or few things to remember, okay, before we go for this lab part. One thing is that the latency, right? The latency check, what ZCC does, this check only happens to the gen, or to gen means data center, right? It doesn't check for any other any IP or any other domain, right? Because the path is from ZCC to Zscaler data center, right? There is no way it checks further from the data center to any other a destination. Okay, the latency based ZEN selection, this is purely right, pure latency based. Okay, it doesn't consider the bandwidth. Okay, it doesn't consider the throughput, only the latency. All right, that's one thing. Okay, and you already know that the failover mechanism it does is the HTTP probes. Okay, and these HTTP probes and that's a transaction, not basically based on per packet, right? It's the first byte it reads, and based on that it detects the latency and it calculates the latency. So this is the basic about how it does. We know what is configured on the portal, right? And we're gonna replicate this in our lab. So to do this in a lab, what we need to do basically, we need to check few things. So let me just do one thing. This is our ZCC running. Let me check what is though we don't have to check it, right? We already know that this Zscaler is connected to the server, which is SVPN node is this, right? 165, 225, 124, 75. The highlighted one you can see. Uh, when we have a latency higher on this, then it's gonna fail over to the secondary. So let's see what is the secondary and what is the primary ZEN. Okay, so I'll do one thing very quickly. Let me do one thing. Let me check the ZSA tunnel log. Okay, so all right, so okay, so this is our ZSA tunnel logs. All right, and now I'm gonna do one thing. I'm gonna find out what's the find proxy. So this is the find proxy. This will tell us the proxy, pack file download. or downloaded on this, right? So you can see here, this is a pack file downloaded for, okay, tunnel version. What is this tunnel version? It's, so this pack file is for tunnel version 2.0. You can see this is the statements, and the default statement what you can see here is basically this, right? So the primary node is 165, 225, 124, 57. And we can see same in the Zscaler data center, 165, 225, 124, 57. Okay, let's just copy this to our notepad. Okay, the previous one here. Now, when we have a higher latency on this, then only it's gonna fail over to this, right? To do that part, what we have a software downloaded that called Clumsy. You can download that software from where you can download it. Basically, you can download it from the GitHub site, right? It's freely available, and based on this, you can uh, perform the few. You can modify a few things, right? That you can generate high latency on certain IP or you know or range, right? There are a couple of options. So we have this to generate a higher latency part. What we're gonna do basically before that, right? Let me just quickly show you one more thing. All right, so this is the AC tunnel to check the latency, right, or the you know the load latency based gen. We have a keyword to check these logs, and that called LBZ. That's called latency based Zen. When you filter for this keyword in ZSK tunnel logs, you would see the uh, the the logs right related to the latency. Okay, now there are two type of log you can see. One is called ZST2C colon LBZ, and there is Zscaler PHM, ZPHM, so colon LBZ, right? So these are two type of logs, okay? And these logs are basically this the first one, which is Zscaler. So what do you call it? Zscaler tunnel 2 control channel, and this is latency based selection. That's for the tunnel 2.0 case. Okay, when your Zscaler is running on tunnel 2.0. Now this other one, which is ZPHM, that's called Zscaler proxy health management, and this is again latency based Zen. This is in case of tunnel 1.0. So this feature works in both cases, tunnel 1.0 and tunnel 2.0. One thing to remember, uh, GCC will do latency based check for the both tunnel 1.0 or tunnel 2.0, because we would have the gen or SME IP addresses in for the tunnel 1.0 and tunnel 2.0, because ZCC downloads both these pack files. Okay, and that's always there for the failover purpose. One thing. Other thing, important thing to remember is basically, and I think that I'll cover later on in our training further. So we know how to filter the logs, right? Okay. Now what we're gonna do basically for tunnel 2.0, tunnel 1.0, we know, right? Let me just do one thing. Let me just change the latency for the primary IP address, and this is gonna do one thing. This is gonna fail over our tunnel to secondary tunnel. Okay. Oh, let me just see the first, right? Okay, so you see what we have currently, right? So the time this is, okay, let me just check the time what we are on is basically 6:27 UTC. So you see 6:25. Okay, now let me open this Clumsy software and all packet. Okay, let me select all IPv4, again the specific IP, right? So we get this, we get a filter, and what we have to filter for basically, we need to do it for the primary Zen, right? And then only it's gonna fail over to the secondary. So I'll type IP address there. So basically 165.225.124.57. And this is again source destination both. So let me write it once again, 165.225.124.57, right? You know, this is the primary Zscaler data center, And how do we verify? So you can check ip.zscaler.com, and this is the New Delhi data center, right? You see, this is the New Delhi data center, Zscaler cloud, and pack at shapeskills is logged in, right? Now let me do one thing. When this failover would happen, you would see the notification as well in the notification section. Okay, let me clear it. And let's just do one thing. Let's just select that latency, the lag, and let's just increase it to 1000 millisecond of delay. Let's just introduce 1000 millisecond of delay. Okay, and let me start this. So now I started this delay for this particular primary SVPN IP address, right? The 1000 millisecond of delay. What gonna happen? ZCC gonna send the probes, right? And we know how many probes based on our configuration, right? It's gonna send 3 probes in 3 second of interval, and then it's gonna fail over. So let me go to the lab itself, and you're gonna see it here. Okay, once that happens, so we'll have to wait for how much time? 30 second, 30 second, 30 second. So we have to wait for that 90 second, right? Meanwhile, that happens. Let me tell you a few other things. Okay. Mm, what else we can tell you here? Basically, I think we have covered everything for this feature. So what we need to do is basically wait, right? Wait and watch. When that failover happens, we're gonna see that happening in the ZCC. We will have a notification here. We will have a change in IP address from the New Delhi data center to the secondary data center, most probably Mumbai, right? And let me confirm that 165, 225, 1. Okay, you see, ZIA tunnel switched to another instance for optimal performance. Zscaler client character, and we should see a notification. Oh my God, do you see? So there is a notification now, and if you check the IP address, it's 165, 225, 120. This has changed. And let me just do one thing. Let me go ahead and refresh ip.zscaler, and you can see now, without doing anything, just based on the latency, the ZCC tunnel switched from Delhi to Mumbai. The tunnel version is still tunnel 2.0 DTLS, right? And we can see it here, in the notification section as well. So this is the feature which is very useful, right? This will, you know, uh, of course, improve the user experience, because if users are experiencing problem slowness, right, or latency toward a specific data center, the primary, they can fail over to the secondary one if you have this feature enabled without making any changes, and again vice versa. So this happened there. Okay, let me do one more thing again. Let me just stop this delay. Once we stop this delay, the failover gonna happen from secondary to primary, because that's again, right, it's gonna send 3 probes, 30 30 30 second in 90 second of interval. It's gonna calculate that that delay, the latency, and it's gonna fail over from the secondary to primary if it finds that latency to which is secondary now, which was primary Delhi, is lower than the Mumbai, and which it will be, because I'm near to Delhi, so I'm certain that this is going to happen. Let me just show you here that there will be a notification, and there will be a switch to the server IP address, and there will be, I mean, we will reference the ip.zscaler as well to see. Okay, let's wait for a 90 seconds. Okay, one more thing to tell you regarding the probes, right? So the probes, in case of tunnel 1.0, how it goes, let's say it sends a probe 1, right? And then it sends a probe 2, the HTTP probe 1, probe 2, and then it sends a probe 3. Then it calculates, and then it takes a decision, the ZCC, right? Now, in the next try, it uses the last 2 probes from the previous attempt, right? So it would use the probe 2 and probe 3 from the last attempt, and that would become probe 1 and probe 2 for the next check. And it would do a one more, the third check, and that would become a second, the third probe for this. and then it would calculate, right, the latency, and then it would fail over. So this is how the incremental check happens in case of tunnel 2.0. In case of tunnel 1.0, it would start from the beginning. So it would do one probe, two probe, three probe, calculate, failover. It check whether it has to do failover or not, and then it decides. If no, then it checks again, one, two, three. Again, GCC calculate, no failover, one, two, three. Right. So that how uh, check happens for tunnel 1.0 case. We're gonna see this all in our logs. Okay. So it may gonna it may gonna happen in some time because I think we're gonna touch the 90 seconds time, and once that happens, this failover gonna happen to the New Delhi data center, and we would see, of course, a notification there right here, and server IP change, right? Okay, let's wait for a while. Do. Okay, so this is what we gonna do. Let me see. Yeah, so meanwhile, I'll tell you how you can download that, the software Clumsy, if you want to do this in your internal lab, and you're gonna perform this, this testing. So you search Clumsy in the Google search, right? And you get a very first page, the download page from the GitHub. You go to the GitHub page and you download. You can download the latest one, right? The 0.3 based on your operating system version. Okay, that's something you. And this is available for Windows, I think Linux as well. Okay, let's see if this has changed. No, so far no. Mm, Okay, so meanwhile this is doing its task. Let me open the ZCC logs, and let us filter for the logs, right? So gen based latency based gen, that's a keyword which would filter all the logs related to latency, tunnel 1.0, tunnel 2.0 both. Okay, now we are interested in tunnel 2.0 because Zscaler is running in the tunnel 2.0, right? Okay, all right, so and if it's not doing due to some reason, we would see, right, looks like the time has passed. So Zscaler ZST2C, that means Zscaler tunnel 2 control channel LW, right? So the timing, we are around 6:36 26 UTC, right? So okay, all right, so you can see it here. I think around 6:20 or 620, 627, 637. That's where it is. So we already have that feature enabled. So what it's doing, it's keep checking it, right? So what you can see, let's say here, let's just start it from here. There is a latency sample size 0, right? This is to the Z tunnel 2A for the tunnel 1, and this is the ZEN, okay? The 124.57, it's 120 now, okay? And this is the latency 2 17, right? For tunnel 2, for the backup, this is the latency. The sample 3 to 1 is this, and sample 2 is this. That means there is a 3 sample it has collected, and this is was the latency. So for the tunnel 1, this is the latency, and 2, this is the latency. Okay, now what it did now on a next check, you can see this one, the first sample size 0 is the sample size 2 here. You see, 184 milliseconds, 196 millisecond, right? And the third is the second sample 011 here. And this is the next new sample it did. It calculated that latency again. Okay, that how it happens changing. Okay, now I think this is where we introduce this latency, right? You see, now so far based on these right tunnels, so the ZIA tunnel 1 latency is less, right? Zscaler tunnel 2A means primary data center, B means secondary data center, right? So here latency to the primary data center is less. You see, now what happened? We introduced that check, right? The extra latency, the latency increased to the to the primary data center. You can see first check, second check, third check, right? So the three probe it sent, right? After these three probe, it calculated, right? And it found that, oh, latency to the primary is higher. Okay, so what it does, it changes that instance from primary to secondary, right? I mean from tunnel 1 to tunnel, I mean primary to secondary, of course. And this is, you can see 626 uh, 6. Okay, this is in IST and that's in UTC. We can change it, but yeah, this is what happened. Okay, the changes happened that time, and that's how we saw uh, that tunnel failover to the secondary. Okay, and then keep checking the latency. You could see uh, is on a higher side on a tunnel 2.0. The secondary tunnel again. It's keep checking this process again and again, and then it's calculating where is the latency, where is the high latency. Okay, so now we could see now the latency on a primary node. Okay, 1 2 3 here. Why it's not failing over? Let me just refresh this log, bro. Okay, let's just refresh the log once again to see if we have update. Now the time we have here in UTC, it is 6:40. Okay, 6:40. Okay, is it doing something? Yeah. You see, 26, 30, 120, 57, 124. Let's refresh it. Okay. I'm not sure why it's not doing it. Okay, this is not doing it because if you see, right, the latency, you can see the latency on a primary node is less, right? Here, based on this calculation, there is just a 1 millisecond less, and this is I think 30-35 millisecond less. But it should be, right, to failover from secondary to primary, it should be what more than 30%, right? And what we have configured, that it should be threshold 1, which is more than 30% latency difference, right? So what we're gonna do in this case, since it's not happening automatically, and I was thinking that this is gonna happen, but it's not happening. So what I gonna do basically, I'll open the software and will manually do it. Okay, let's not wait for it to happen. So we have opened that software once again. Okay, and let's just add a filter to a specific IP address, and that specific IP address is 165.225.120.57. Okay, now I select this IP, I put this IP here as well. Okay, now I add some lag. Let's add it around 1000 milliseconds. Okay, and let's just start this process. The process we started, it is around 6:42 UTC. Okay, so we're gonna see these logs as well. So let's wait for 90 milliseconds. Oh no, not 90 milliseconds, but 90 seconds, right? This is in seconds, not in milliseconds. So let's wait for 90 seconds, 1 2 3 probes, and we should have the tunnel failover. Let's just quickly check. Okay, let's see if we have some update. Let's scroll it down, and you can see latency has not increased so far. Am I adding the right IP? Let's see, 165.225.120.57. Yes. Or okay. Oh, I didn't start it. My bad. Now I started 165.225.120.57. Yeah, that's the same IP. Let me refresh the tunnel logs to see. Okay, let's go to the bottom. to see the latest log, and then this is okay. Looks like it's not. We don't have the latest log yet. Let's filter. No. Yeah, just refresh this way and then filter. Okay, I don't see this is happening. Oh, I see it now. This is what I see. 4000 millisecond latency to tunnel 2.0b, which is 120.57, which is our current Mumbai DC. You see? So that is now working. We'll have to wait, right? Because it's based on time. So I think 30 millisecond passed and we see one probe sent. Now let's wait for another probe. I think we'll have to just refresh the tunnel log first and search for it. Okay, oh my God, I see this pop-up now. That's what we were waiting for. Now you see it's 124.57, 165, 125, 124.57. The you see the notification is there, and earlier we were sending traffic to Mumbai. I'll refresh this, and now I see the traffic is going to the New Delhi data center. So this is how, right, this works. And let me just quickly go through the logs as well. Okay, so three keywords to find the log in the ZSA tunnel. The first keyword is ZST2C colon LBZ, right? Just a keyword LBZ would also work. And then ZPHM, Zscaler Proxy Health Management colon LBZ to see the tunnel 1.0. Okay, so let's see. You can see now there were three attempts, right? So the first attempt you see it here. No, I think the logs are not updated. Search it now. Now we are at the bottom of this page. Let's go here. Okay. Yes. You see the change happened here because the tunnel latency 1, 2, 3. So three times the latency was on a higher side, right? And the tunnel change, happened. Okay. And then it's again checking as usual. All right. The second keyword, what I was saying is simply you remove this Zscaler tunnel 2.0 filter, and you would see all these logs. If you want to only check for tunnel 1.0, because if you're running on a tunnel 1.0, you just check for this keyword and you would see only tunnel 1.0. So tunnel 1.0 we won't see anything because we're not running on tunnel 1.0, right? There we would see the same thing. So you see three probe it sent, it has calculated the latency. And one thing to remember, the latency calculation for tunnel 1.0 and the tunnel 2.0, they'll be different. Okay, the IP will be different because in this case this is for the SVPN. For the tunnel 2.0 case, it's for the SVPN, this latency happening. In case of tunnel 2.0, this is a different, you see 124.25 you see, and 120.25, but it's 124.57 New Delhi DC, right? So that two different IP uh, based on the pack download, right? And you see three time it downloaded, it checked, it says threshold didn't match, right? It again started checking, and then again we have a result. So this is how the tunnel 1.0 failover works and the log mechanism. I hope you like this video and you get some idea about how this works. uh, so yep, that's all for today's. See you in our next training. Bye.